everybody, welcome back to another Gregorius Maths video. Today, as promised, I'm going to be making a video on a general formula to solve quadratics in the form ax squared plus bx plus c equals 0. Okay? Now, this formula works for any a, b and c as long as a is not equal to 0. Okay? Now, what we're going to do may not seem very obvious, okay? But in the end, it will work out. So, the first step is to subtract c. That makes sense. So that means that ax squared plus bx equals negative c. Okay? Now, here comes the stuff which might seem confusing. We're actually going to multiply by 4a on both sides. So this means that 4a squared x squared, okay, because 4a times a is 4a squared x squared, plus 4abx equals negative 4ac. Okay? And now we're going to add b squared. So this all looks way more complicated than we started with. So now we have 4a squared x squared plus 4abx plus b squared, okay, equals b squared minus 4ac. Okay, because minus 4ac plus b squared is equal to 4ac, is equal to this. Okay. However, if we take a closer look, it actually turns out that this here is a perfect square. Why? Well, here we have b squared, so it's going to be plus b, all squared. Okay? Now, this part is the 2ab. b is b. The 2a must be 2ax. So actually this is 2ax plus b all squared. And when we do this, well, this here is 2ax squared is 2 squared, which is 4, a squared, x squared, plus 2 times that is 2 axb plus b squared. Okay? And this equals b squared minus 4ac. Now, taking the square root on both sides leaves us with a much easier equation to deal with. So, taking the square root gets rid of this squared. So 2ax plus b is equal to plus minus the square root of b squared minus 4ac. Okay? The plus minus comes because, like, negative a squared is equal to a squared. Okay? So you should always remember to consider the negative version of the square root too. That's why most quadratics have two solutions. Okay? Now it's a linear equation. So subtracting b leaves us with 2ax equals negative b plus minus the square root of b squared minus 4ac. And now dividing both sides by 2a leaves us with x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? I'm not gonna say I came up with that song, okay? But that song does help me. It's from a channel called Dorfuchs, Dorfuchs, who normally does German maths content, but on the occasion he does have an English song. Okay, one of them was about this quadratic formula. Okay. And this works for any numbers a, b, and c, okay? As long as a is not equal to 0. Because if a were equal to 0, a, this wouldn't be a quadratic, and b, we'd have to divide by 0, which is not good, okay? So, let's look at one example of something really cool called the golden ratio. And the golden ratio is actually the solution to a quadratic. Now, I will use the Greek letter phi, because that's usually what's used to denote it, okay? but you can use any letter you want, okay? So, phi squared minus phi minus 1 is equal to 0. Okay, now the golden ratio is the solution to this quadratic. Now, phi is equal to negative b plus minus square root of this, okay? What is b? Well, b in this case is 1, okay? So this implies that phi is equal to negative 1 plus or minus the square root of b was negative 1 squared, which is 1, minus 4ac. Well, a is 1, c is negative 1, 4 minus times minus becomes plus 4, and then divided by a with 2a, which is 1 times 2, which is 2. Now, this equals to negative 1 plus minus the square root of 5 divided by 2. Why is this so cool? Well, actually, without going on too much of a rant about the golden ratio, there is something really cool we can do, okay? Yeah, this will maybe blow your mind. I can't guarantee anything. Well, this here also implies if we just ignore these steps, we do the normal stuff. Add this on both sides, add this on both sides. So we get phi squared equals 1 plus phi. Now taking the square root on both sides, we're left with phi is equal to the square root of 1 plus phi. Okay? Now, here's where things get very, very interesting. We have phi equals the square root of 1 plus phi. So why don't we substitute phi? Okay, so this means that phi is equal to the square root of 1 plus, and now phi is the square root of 1 plus phi. Okay, do you see where that comes from? Phi is the square root of 1 plus phi. But we have phi here as well, so we can do this. Okay? Now we can do this whole thing again. Phi is equal to the square root of 1 plus the square root of 1 plus the square root of 1 plus phi. And we can do this forever. So overall we're left with phi equals the square root of 1 plus the square root of 1 plus the square root of 1 plus the square root. And we can do this forever. Isn't that amazing? This is equal to that. Okay? Now you can do the same thing, but instead of taking the square root on both sides, you can divide both sides by phi. Okay? And you're left with phi 1 over phi plus 1 equals phi. And you do the exact same thing. And you get an infinite fraction too. So this is a really cool example of a quadratic formula. And remember that this number here comes, a quadratic equation, comes from a quadratic equation. So the quadratic equation, while may sometimes be seen boring, can lead to some beautiful, fun results. Goodbye.